Hey everyone, so today I want to kind of go over chapter 8 with you. Um, Hold on, let me get my computer to share this screen real quick. Okay, and so like I said, I want to go over lesson 1, chapter 8, algebraic reasoning, graphing, and connections with geometry. All right, my name is Heather McPherson, and I hope that this lesson kind of gives you a deeper understanding of graphs and how we use them in almost everyday life. So with the first question, the following slide is going to show you a couple of different graphs. We have 4 scenarios here. Gas in a gas tank when a driver refills the tank on a drive across country. B is the height of an elevator stopping at each floor. C is the height of a bouncing ball dropped from the table. And D is the length of a shadow of a flagpole throughout the sunny day. So here we have 4 different graphs. These are the 4 that are chosen, and you can just take a look at them. You know the scenarios that you're working with, and you can kind of pinpoint which ones would go for what. So with this first one over here, let me get my pointer. So this first graph right here, we know we have a starting point, and then it declines, and then it increases without any movement, and then it declines again. So I would do this one as A, your scenario A, which we would have the amount of fuel, and then your x-axis would be the distance that you're traveling. Now take a look over at this one right to your right, and it's got a lot of stops. You have a lot of points on this graph. So for me, I would automatically know that's the elevator. So B is your floors versus your elevator stops. Sorry. Now your third graph is a squiggly line. Well, we all know when you drop a bouncy ball, it goes crazy. So automatically I would have looked at this graph and knew that one was the bouncy ball. And so C, and you have the height of the table, which is where you start, and then the distance the ball bounces. Every time it bounces, it goes higher, and then it starts to dwindle until it stops. Now your last one would be your flagpole. So you'd have the sun rising or setting versus your flagpole shadow. You can use a lot of different graphs. These are just the ones that I chose to use for these examples. All right, next we're going to look at the composition of f and g. So you have f of x equals f of g of x. So here we have our problems. They want us to find g of f of 0, 1, 2, and 3. So we know f of x equals 3, and g of f of x equals x plus 8. I know, a lot of jumbled up words in that one. So what I do is I would make a table first. So this table shows our values of x because we're wanting to look for 0, 1, 2, and 3. The second part of it is f of x equals 3x. So we know that our values of x are 0, 1, 2, and 3. So we would place those into this equation where the x is. 3 times 0 equals 0. 3 times 1 equals 3. 3 times 2 equals 6. And 3 times 3 equals 9. So now that we know what f of x equals, what we're looking for is the g of f of x. So g of f of x equals x plus 8. So we wouldn't go back and use 0 because we already know what f of x equals. So you do, this one of course will be 0 because 3 times 0 was 0. So you'd use the second column when you're trying to figure out this third column. You have 0 plus 8 will equal 8. 3 plus 8 will equal 11. 6 plus 8 equals 14. And 9 plus 8 equals 17. So now that we have our table done, we can make our plots. We can put our plots together on a graph. And so as you can see in this graph, if the blue line is going to be your f of x, and your orange line is the g of f of x. So we said 0, 0. Then you have 1 and 3, 2 and 6, 3 and 9. Same as this orange one, you're going to have 0 and 8, 1 and 11, 2, 14, and 3, 17. As you can see, this graph increases, so the line is sloping up. Next, we're going to talk about slopes of line segments. Remember that sorry, my face is kind of blocking this part right here. Your equation for a slope is going to be y2 minus y1 over x2 minus x1 when you're given 2 points of the line to figure out the slope. So this first one, you're given your x's and y's, so you have 3 and 1 and 5 and 5. So we're going to plot that, and I've already kind of got this one done. So our lines, our points on the line are going to be 3 and 1 right here and 5 and 5. So when we connect those, you see the line, and we can have a triangle drawn into it. Now there's several ways that you can do this. I'll show you in a later one what we're going to do. But the same as 5 and 8 and 5 and negative 8, when you graph it, it's just a straight line. So you know that there's no slope here. With this first one, your line is sloping upwards. So you go up, and then to your right is how your line is sloping. Again, this one doesn't have a slope, so it is straight up and down would be vertical. All right, now let's see this one. We have the points -1, -4, and -4 and -13. Now what I did is I already put the points on here, -1, -4, and -4 and 13. Take a look at this graph though, and you need to be aware of how you're increasing on your x and y axis. So you see my x-axis goes up only by 0.5 when my y-axis goes up by 2. You need to know that in the next part. So we're going to change to the pen real quick. So our slope equation again is m equals y2 minus y1 over x2 minus x1. All right, so we'll look at our table again. You have your x values and you have your y values. So, this is the first one, first set of points, and this is the second set of points. So when you're looking to put in your values into the equation, you'll know that this will be under x1, y1, and this will be x2, y2. So then you would have -13. And since it's a negative, we're going to put it in parentheses, minus, again, parentheses, -4. And then you're going to have over -4 minus -1. Again, I just got those from the table up there. And a -13 is your y2, -4 is your y1. -4 is your x2, and -1 is your x1. So -13 minus -4 will be -13 plus 4 equals -9 over -3. Well, we know this can also simplify some more. So 3 goes into 9 3 times. 3 goes into 3 1 time. So you're going to have a slope of 3. You have a negative over negative, so it's a positive. You can also look at, at the graph itself. And like I said, make sure you know how your graph is increasing or decreasing. So if we go from our point -4 to -13, okay, we go up 1. There's 1. Remember, this goes up by 2's now. So you have 3, 5, 7, and 9. That's the same line that point's on. So that went up 9. And then this is done in halves. So you'd have 0.5 to 1, 0.5 to 2, 0.5 to 3. So you have 3. So you have a rise of 9 and a run of 3. So your slope would still equal 3. And you can go ahead and draw a line to make your triangle. So I know it's not straight, but you can see the point of it. And then you would know that it goes up and then to your right. Now, we want to look at a couple of functions and graph them and see the similarities and the differences between them all. So we have y equals x squared, y equals x squared plus 7, and y equals x squared minus 7. So looking at these, we know we're looking at parabolas. So a graphing calculator, its normal window is about -10 to 10, so that's what I'm kind of using as my values of x, if you can see here. And I have all of the equations written in. So you have x or y equals x squared, so you would do -10 squared equals 100, and then just all the way down to +10. Same with the x squared plus 7 and x squared minus 7. Once we have the table set up, we kind of know a gist of what our points are going to be within the graph. And I always look at 0. So if my x is 0, where are my y's going to be with each equation? And as we can see, the first equation is going to be 0, 0, then 0, 7, and 0, -7. So those are the first points I would put on a graph. And when we look at these 3 graphs, we see that we have a 0, 0, 0, -7, and a 0, +7. So we have our starting, and again, look at the parabolas. You can see that the graphs are pretty similar. The only thing is they start at different points, but they grow at the same way, and they look like the same line. So if we were to say that take out the +7 here, it would be the same as the x squared graph right here. You're just growing by 7 or you're decreasing by 7. Next, I want to look at the equation of a line through the given point that is perpendicular to the given line. So again, my x values are going to be -10 to +10. And my first equation is y equals -3/4 x plus 5. So we know that the original line equation is right here. And so we're going to plug in our x values into this equation, and we come up with all of these answers. You know your point is 0, 5 is your first point that you'd plot on the graph. Now, we're looking for the perpendicular line. So we have the line R. We have line R, and the only points that we're given are 6 and -1. So that's the only line we can plot into the graph. And as you can see, we have all of our plots on the original line, and we plotted the 6, -1 right here in the orange. Now, you can find different points of the line. Right here, when you draw out your line, this one says it would be 10 and 5. And so when you go look over here, you see that the line is perpendicular because of the right angle. How do we know it's a right angle? Well, we can put this square in and see that each square has right angles all the way through, so it fits perfectly. Let's go ahead and change this color real quick. They give us the equation 2y plus 9x minus 5 equals 0 with a line point of 0, 3. So we know that the equation y has to be on the left side by itself. So we're going to have 2y equals, and we're moving everything to the right. So since this was a positive, it's now going to be a negative 9x. And then that was a negative, so it's going to be a positive plus 5. Well, the y is still not by itself, so we're going to divide both sides by 2. So you would get y equals negative 9/2 x plus 5/2 as your equation of your original line. So once we know the original equation, we can go ahead and again use these same negative 10 to 10 values for x. And we're going to plug those in to the original equation to come up with the points of the line. Now the perpendicular line, again, we said has points of 0, 3. So you find 0 and put 3. Now, again, this is where we pointed it, 0 and 3 for your perpendicular line. All right, now we're working with tangent lines. Here I just have, it's pretty much a graph. We have the y-axis and the x-axis right here. And what I'm going to do is I'm going to go ahead and draw a square that connects a perfect square that has the same size, same length times height. Now we're looking at the problem is a circle with a radius of 9. So within this square, I'm going to go ahead and draw my circle. And I know that from the middle of the circle to the outside of the circle, that radius is 9. So my points are going to be 0, 9, because of the radius. It's going to be 9, 0 on the x-axis, 0, negative 9, and negative 9, 0. So those are all my points for my circle. Now we're looking for the tangent line. So right here we have the tangent line on 0, negative 9. So you'd have y equals negative 9. And then you'd have your tangent line on the 0, 9. You'd have y equals 9. Now they look similar and all, but know that the tangent line for 0, 9 is always going to be a positive 9, and the tangent line for 0, negative 9 is going to be negative 9. I hope I helped you understand a little bit more about graphs and perpendicular lines, tangent lines, and all of that. I know it was a lot to throw at you, so I hope you all have a good day, and thank you.